Hey guys, Mrs. Kane here. So I just want to real quick show you guys a shorthand way of doing electron configuration. Okay, and the reason we do this is some of our elements, like if you look, strontium has 38 electrons. And I went ahead and did our longhand notation, and you can see that it is a lot. Okay, we end in our 5s2. So we got quite a few energy shells, and that can get really tedious to write that all out. Okay, so what we do with our shorthand or noble gas configuration is we look at our periodic table, okay, and we find our element. So here's strontium, and we are going to go to the noble gas that is behind it. Okay, so krypton has 36 electrons. Okay, and strontium has 38. So you want to move backwards so you can still compare them. Okay, if we move forward and we compare strontium, okay, to xenon, xenon has a lot more electrons. Okay, so its electron configuration will keep going way beyond where strontium is. That's not good. That doesn't give us a shorthand way because those don't have similarities. Okay, at least not as close as krypton with 36 and strontium with 38. So when I write out the electron configuration for krypton, okay, you'll notice that it is almost exactly the same as strontium's, except strontium continues for 2 more electrons into the 5s2. Okay, so one way that we can make our lives a little easier is by using this notation. Okay, and what we do is we say krypton is our closest noble gas to strontium. So I'm going to put it in brackets. Okay, strontium continues past krypton's noble gas configuration to 5s2. So this is where they're different. And if you're looking, okay, here's 4p6. It's in both of them. Okay, krypton ends there, but strontium keeps going. So all we're doing is we're taking what's extra on strontium and adding that. Rhea, honey, it's okay. Sorry, guys. It thundered a bit and my dog's freaking out. She's all right, though. So we add the extra piece of our electron configuration after that noble gas. So it's our way of saying strontium is the same as krypton, plus we filled our 5s2 orbital. Okay, so this is just a short way of writing this big old thing. Okay, so that's a shorthand way of doing electron configuration. Okay, give me a second. I'm going to put one more example up for you. All right, guys. So again, I'm showing you another example of shorthand notation for electron configuration. So we're going to look at cesium, which has 55 electrons, and it ends in our 6s1. So just to show you on our periodic table, okay, when we're looking at our periods, they represent our ends. Okay, so here's n equals 1, 2, 3, 4, 5, 6. So we're in 6, okay, and we are in the S block. So this is 6S, and we're in the first column, so that's 1. So that's how I got with the ends in 6S1. Okay, so now we're going to come back to cesium, okay, which is 55, and we're going to go back to our noble gases, and we're going to find the one that's closest. So xenon has 54 electrons, so it is the closest to cesium. Okay, they only have a difference of 1. So to do my noble gas configuration, I'm going to take my noble gas that's closest to cesium, which is xenon. I'm going to put it in brackets, okay, which is my way of saying same electron configuration, but we have to add on what's different. So 6s1. So xenon in brackets, 6s1, is going to be equal to cesium's noble gas configuration. Okay. And like I said, quick intro to shorthand way to do noble gas configuration. Got any questions? Come see me for office hours. All right, guys, good luck.